We have these high efficient axial piston pumps we call APP pumps. These are based on the positive displacement pump concept, and they are available in different sizes, coming from flows from 0.15 and all the way up to 92 cubic meters per hour. The typical pressure that we operate is in the range of 20-30 bars and up to 83 bars. The materials that we are using is all super duplex or duplex steel, depending on what applications we are going into. The pumps are designed in a way that you can put as many of them in parallel as you wish. That's the beauty about these positive displacement pumps, that they are not really affected by each other. So when you put them in parallel, you can mix them as you wish to obtain the flow that you need. So the beauty about positive displacement pump is as well that they are very efficient. This is, of course, impacting the OPEX for the users. As these pumps have the lowest energy consumption, there will be a significant savings when using them compared to other technologies. With the APP pumps, you get the efficiency rates up to 92%, which is up to 16% better than other pump technologies on the market. The positive displacement pumps are controlling their flow through the RPMs of the motors, that the efficiency is constant. No matter what RPMs you operate at, you will have the proportion flow versus RPMs coming out of the pump. So the efficiency stays the same no matter if you operate at low pressure or high pressure. It doesn't really affect the pump as such. So because the pumps is rotating at a they rotate up to 1800 RPMs, and they are very small in the footprint because of this concept of having a cylinder barrel rotating. They take up very little space, and because of the sizes, it fits everywhere and can be placed both horizontally and vertically. That makes them easy to service. Handling of the pumps in remote areas is very easy. There's no need for heavy lifting equipment. And like Miguel was saying, when you get on board on a ship where space is limited, these pumps are really very easy to find space for and get installed. The RPMs, as I said, was proportional to the flow. So if you are adjusting or need to adjust your flow on your membranes, you either speed them up, or if you want to reduce, you speed them down, and the flow will change accordingly. And again, you can do this independent. If you have more pumps in parallel, you can have maybe 2 or 3 of them running direct online, and then just have one pump operating with a frequency drive on, and do all the fine tuning on that specific pump. The APP pumps, they offer easy and predictable operation. They are increasing the reliability and reducing the OPEX. And this is due to the full control of the life cycle cost and the service intervals that is needed for them. We are specifying for each, all the wear parts have specified the service life, and we are able to control the cost on the service due to this. There's no oil in the pump, so you don't have to change any oils, and there's no lubrication needed besides what you get from the fluided pumps. And there's therefore also no risk of contamination of the water that you're pumping. There's no special alignment needed. All the pumps are mounted with a fixed bell housing. And this basically means that when you install the pumps or do service on the pumps and you take them off the electric motors, there's no really risk of error, as the motors will always be aligned perfectly by the fixed bell housing. And they are easy to install because of everything is set up from the start. Besides the pumps, we also have these the iSaves, ERDs. They are built on the isobaric pressure exchanger concept. The iSaves are coming in different variances or sizes, just like the pumps. We have the iSave 21, that is the smallest one we have, that comes 6 to 22 cubic meters, and we have them all the way up to the iSave 70. We also have a MPE 70, which is a pressure exchanger concept that is more used into bigger RO systems. The iSaves is a unit that is consisting of both the vane pump or booster pump and also the pressure exchanger. The pressure rating of these they are operating up to a pressure of 83 bars. And it's basically utilizing the same technology as on the wear parts as we use in our axial piston pumps. So some of the valve systems and so on is coming from that technology, which Danfoss have been mastered for the last 20 years. The materials is super duplex and duplex steel, which is combined with these carbon fiber reinforced thermoplastics. So for the installations, they are just like the APP pumps, very small due to the technology. We are using a cylinder barrel to the exchanger, and we are using a vane pump for the booster pump. This makes it very compact, and as we have combined all these components into one device. When we say it's a 3-in-1, you can say it's because we have the pressure exchanger, we have a positive displacement pump, which is the vane pump that is used for a booster pump, which is, because it's a positive displacement pump, it also works as a flow meter. Because basically, if you know the RPMs on the iSave, then you also know what flow you're getting out of it on the high pressure side. It's very compact in design, and it's which allows it to produce more water in less space with less complexity. And the iSaves can be placed in both vertical and horizontal position, which makes it easy to install. It's easy to handle it in the field as well, as they are not heavy in the same way as other components or similar components. Then for the iSave ERDs, they offer high energy efficiency, just like the axial piston pumps. This is a mantra for Danfoss. We want to have the most efficient technologies in our portfolio. The exchanger and the iSaves is having an efficiency up to 92%. And this is including the high pressure booster pump. The isobaric pressure exchanger is known as, the technology is known to be the most energy efficient technology on the market. And we're typically offering up to 30% lower energy consumption than other ERD technologies. The control of the iSave makes it easy to optimize your system. All the iSaves are controlled with a VFD. And the VFD will allow you to control the flow on the high pressure side independently of the flows on the low pressure side. And thereby, you are in charge of this application or the installation 100% once it's installed. The iSave ERDs are designed for automatic and fail-safe operation. Basically, the drive will monitor the iSave and make sure that everything is in order. The rotor is spinning, or the rotor spin is controlled by the drive, which eliminates any risk of overspinning or overflowing during commissioning, startups, and during operation. That means you get a very reliable and low maintenance performing ERD. And it makes it also easy to fault find on it, because you know exactly where your ERD is, how it operates, how much flow you get out of it, how much you should get out of it, and what the speed is of the device. Yeah, I guess that's all we had for the iSave on the actual piston pumps, and then we are ready for some questions.